Oh, this is your Captain Shreyas, and welcome to the chapter 1 of class 11th physics of your JEE 2027 preparation. And welcome aboard all the 12th standard students who want to cover up your backlogs right from chapter 1 2. And in case you're preparing for 26, this is for the backlogs purpose. This is obviously the right series for all of you. Well, this is your Captain Shreyas, your physics master teacher, and I have been guiding, mentoring, teaching for more than 13 years. I myself cleared my JEE almost 20 years back. I almost got a full score in physics when I wrote my JEE Advanced examination. I did my BTech from NIT Nagpur and research from IIT Bombay. And thousands of students, I am proud to say, that are nurtured by me who have entered into IITs. So with this, let's begin the class and welcome aboard. You can also give a brief introduction about yourself. Hi, Priyanshu, welcome. Madara, welcome. Everyone, nice to see all of you. Hi, Jason Black. Welcome, Prakshit. Hi, Mitra. Welcome, everyone out here. You guys are my new students and who are going to stay for the next 2 years until you crack the JEE examination in 2027 and some of you maybe in 2026 as well. Hi Getu, Vignesh, good evening my dear students. So this particular series where we are starting, all the chapters of physics, chemistry, mathematics, 6 o'clock 11th standard portions, 8 o'clock 12th standard portions. Okay, you are free to attend both, and we did not want an overlap because some students might have some backlogs of 11th portions. Some students are wanting to learn the 12th standard concepts because you are giving Olympiads or some other entrance examination, maybe early. So even we have a lot of 9th and 10th standard students. I keep checking the age who keep watching our classes and are already a level up, than their peers and their batchmates. Kudos to all of you. Keep it up. Keep that same enthusiasm. And after every class, we keep a homework question. Make sure you're solving that homework and putting the answers in the comments. Just like our last lecture. Yep, let's see. Where did it go? Yes, the areas and integration. That was the basic of mathematics, which is needed for your physics purposes. Smash that like button, mark your attendance. Many people forget to do that. Yeah, please do it. So very good, Fashion World. Aliza, too good, to go, Doberman. Yes, very good, Devi. Chandru, Sulochana, Durga, welcome, Niranjan. Awesome. Many of you gave the answers correctly. So keep posting your answers of your homework question after the session is over in the comments, and the PDF will be available also in the pinned comments or even in the description box. All right. So that's about it. Let's begin. Yes. Yes. The speed is good enough for 9th standard also. And there are a lot of students in 9th who understand whatever I'm teaching, which means that I'm teaching in a very simple manner. I do not make it sound very complicated. So that's something which I'm proud of, I can say. Hi Rishwant, hi Shravya, welcome. Hi Deva, good evening. So let's begin. And today we are going to do a part of the chapter, and that is units and the dimensions part. We split the chapter into multiple lectures. There is no marathon and there is no question of getting bored after 3 hours because the lectures are short, sweet, and to the point with full of energy. Okay, so that's the best part about these classes. So let's start. Physical quantity. Let's start with the concept of physical quantity. Now, physical quantity means anything which can be measured. Physical quantity means any anything anything that can be measured, anything that can be measured, anything that can be measured. Physical quantities can be classified in multiple ways. Like somebody can say, I can classify physical quantities as scalars and vectors. Scalars and vectors. Scalars are the ones who can be defined just by their magnitude alone. Who can be defined just by their magnitude alone. Vectors are the ones who need magnitude, and the direction for their description. Both. So let me give you some examples. Say when we talk about temperature. Temperature. It is definitely a physical quantity because you can measure it with some number. But if I ask you fever, fever, do you have fever? Yes, I have a fever of 200. I have a fever of 100. 100 is the temperature that you might have, but fever does not have any value. Yeah. I'm feeling tired. How tired are you feeling? I'm feeling very tired. I'm not at all feeling tired. I'm somewhat feeling tired. It can't be associated with a number along with it. I'm very energetic. I'm very enthusiastic. I'm very, very enthusiastic. How enthusiastic are you? Can you measure it in some number like joules? Definitely not. But I have a lot of energy with me. I can measure that energy in calories or joules. There is a number which can be associated with it. Speed, how fast you are going, is basically speed. That is a physical quantity. Happiness, on the other hand, it can't be measured, so it is not a physical quantity. So whenever you have a number associated with something, that becomes a physical quantity. When there is no number, it's just a vague abstract idea, or it's very subjective, it's not objective, then it is said to be not a physical quantity. Is that right, everyone? Yeah, great. Now, when you talk about scalars and vectors, who are scalars and vectors, there is a separate chapter for that. But just to give you a brief idea about examples of scalars, like say for example, time, or let's say speed, or let's say distance. All these things do not require their direction in which things are happening. You just tell, I have traveled 5 kilometers. I have waited for you for 3 minutes. I have gone with a speed of 50 kilometers per hour. That's it. No need of mentioning of the direction. So those are scalar quantities. But vectors, they need direction. Like for example, the force, or let's say the momentum, or let's say, things like velocity. All these are basically vector quantities. I have applied a 10 Newton force in the northeast direction. You need to tell which direction also. You cannot just say I have applied 10 Newton force and like which direction. It matters. What is your momentum? I have a moment of so and so units in this direction. So that momentum will be used to collide with something. I have some velocity. What is your velocity? Difference between speed and velocity is one is scalar, another is vector. So what is your velocity? My velocity is 70 kilometers per hour towards this town in this direction. So when you ask for velocity, you are asking what is your value and what is your direction. But when you ask only for speed, you are just asking for what is your magnitude alone, not bothered about the direction. Is that clear, everyone? Good evening, Sudhir. Hi, Giridharan. Yep. Around 3 lectures, Abhijit. Yeah. But physical quantities can also be classified into two more categories based on whether they are fundamental or they are dependent on each other. So you have something called as the fundamental physical quantities versus something called as the derived quantities. What is the meaning of it? Fundamental means it is very basic. It is very basic. It is not depend. It is not. It is not going to depend on anything else. On anything else. It is very, very different. It's unique. It's very basic. It is very elementary, you can say. Whereas derived, they depend. Whereas derived, they depend on the fundamental. They depend on the fundamental quantities. I will give you a simple example, you will quickly understand it. Say, I tell you, I give you how much distance you have traveled. Okay, that is a fundamental quantity. You can directly measure it with a tape. If I ask you to measure time, you can directly measure it with a watch. Both of them are fundamental quantities. But when I divide distance with time, what I get is speed. Speed depends on distance and time, which are both basic elementary quantities. So speed becomes a derived quantity. Understood, guys? How this works? Everybody with me? So fundamental quantities are those quantities which do not depend on anything else. Another example is the length of a object. I can directly measure it. It is a fundamental quantity. But when I multiply length with breadth, breadth is also fundamental quantity. But when I multiply length with breadth, I get area, and area becomes a derived quantity, and it is dependent on two more quantities. Okay, volume, density, so many other things which depend on the fundamental quantities. Is that clear? So there are fundamental quantities which are directly measured, which are very basic, which are very elementary. They do not depend on something else's measurement. They can be separately measured on its own, but derived quantities need the fundamental quantities to be measured separately. Okay, now the special thing is that you should know that current is fundamental, current is fundamental, and time is also fundamental. Current into time gives me charge. A lot of students make a mistake in this. They think charge is fundamental and current is derived, but current can be directly measured, and when you multiply it with time, how much time has passed, you can get how much charge has passed through a wire or something like that. This concept particularly you will learn in 12th standard, but it's important for you to know that current is fundamental and not the charge. Charge is a derived quantity. Okay, till this point, everything is clear. Let me know quickly in the chat box. Did you understand what is fundamental, what is derived? Did you understand what is scalar, what is vector? Did you understand who is physical quantity and who is not a physical quantity? Anything and everything which can be measured, physical quantity, like temperature or energy or speed. Happiness can't be measured, and enthusiasm or tiredness or feverishness can't be measured, so they are not physical quantities. Any physical quantity can be classified based on whether they need direction or don't, that is scalar and vector, or how basic they are or how dependent they are. So basic means fundamental, derived means they are dependent on these guys like area, volume, density, force, momentum, etc. They are all derived quantities. Yeah, we'll come to supplementary also in a bit. So we have seen physical quantities, all right, fundamental quantities and derived quantities. Now, after this, you will see the concept of how a physical quantity is usually represented. Okay, let's come to that. How physical quantity is usually represented. So let's say there is a physical quantity P. So what is P? P is basically your physical quantity. P is basically your physical quantity. That physical quantity will always have some magnitude associated with it. It will have some magnitude associated with it. Magnitude. Some people also call the magnitude as the value associated with it. So let's say that magnitude is n, and you will always have some unit associated with that particular physical quantity. That unit I can put u. So you will see physical quantity is n times of u. That is a standard formula you would have seen. Let me give you examples. Everything will be clear. Don't worry. Let's say I tell you what is the distance that you have traveled, or let's say what is your speed. Speed symbol is v, distance symbol is d. What is the force that you have applied? What is the let's say for example volume. Okay, what is the volume of something? So all these are physical quantities with their own symbols. P was a generic symbol just to represent some physical quantity. It is just a placeholder. You can replace it with whatever physical quantity symbol you want. Let's say I say the distance traveled is 30. Well, velocity or speed, whatever it is, let's say 72.3. Force that I have applied is 0.57 something. Volume is, let's say, 3.5. Now, what are these? These are numbers, but they will always have some unit. For example, the distance that I have traveled is 30 kilometers. The speed with which I am going is maybe 72.3 meters per second. The force which I applied is 0.57 newtons. Volume is maybe 3.5 meter cube, something like that. So this is unit. You can see number, unit, value, and what is it measured in? Value and what is it measured in? That what is it measured in is basically the unit. Unit is like a standard. Unit is going to be like a standard, meaning without the unit, there is no sense in that value. If I ask you how much force you have applied and you say, sir, I have applied 0.57 force. Like, what is 0.57? Like, what? In terms of what? I have sold 30. You have sold 30 what? Oranges, apples, donkeys. What did I sell? So you need to mention always the units. I have 1 million. Okay, 1 million what? Rupees or dollars or euros. So you will always see some unit preceding some value, without which it doesn't make sense for that physical quantity to exist. Is that absolutely clear? Everyone with me? Yeah, perfecto. It's a standard in which standard in which the physical quantity is measured. Now somebody will say, sir, how do I know that a Newton is a Newton, a meter is a meter, a second is a second? Will a second for me be also a second for you? Will a feet for me be also a feet for you? Will 100 kilometers per hour be also 100 kilometers per hour for some person sitting somewhere else? Will 10 Newton be also 10 Newton for somebody in space? The answer to that lies in the fact that whenever you make a unit, it has to have some criteria, like it has to be easily reproducible, easily reproducible. It should be a standard, and universally accepted, universally accepted. It should not change, it should not change by external factors. It should not change by external factors. These are the qualities which tell me a unit is a unit. I'll tell you. For example, see, somebody says the length of my hand is 1 Pandu unit. Okay. Some fellow over here, he says whatever is this particular length is 1 Pandu unit. Do you think it follows these criteria? I definitely don't think so. I mean, can I get Pandu's hand everywhere? Somewhere else, maybe in America? Oh, Pandu, I need your hand, man, because I have to make a scale. I have to print so many scales. I have to measure so many things. Pandu, please come here. Oh, sorry, boss, I can't come. Can I cut my hand and give it to you? Not possible. Oops, sorry, I just grew in length. My height is growing. My hand length has changed. Gone. It is not a standard. And it will not be changed by external factors. Means like time. As time passes, maybe his hand might become weak, it might become small, or maybe he's growing in age and it has become big. He's growing muscles, it is growing big. Maybe he has grown thin, he's not eating food, so it might become a little bit smaller in size. Who knows? So definitely it can change with external factors. Definitely I can't easily reproduce many pandus with the same hand length. Definitely it is not a standard, and nobody in the universe is going to accept pandu's hand. So we need something which is very, very standard, and that is basically the speed of light. So the way in which a meter has been defined is also very interesting. Like we know speed of light, no matter where, wherever you go, whoever uses, even if you colonize some intergalactic planet somewhere else, speed of light will be the same. Okay, so what we do is we take how much distance does light travel in some 3 lakhs, some 1 upon 3 lakh fraction, of a second, something like that. So you take a big number over there, 1 upon 3 into 10 to the power 8 fraction you take. In that fraction, how much distance does light travel? That is exactly defined as a meter. Okay, so this is why you need something which is standard. You can get light anywhere. Even the manner in which time has been represented as a unit. Guys, 1 second is basically, if you take a particular crystal of quartz and if it vibrates so many times, that number of times when it vibrates, then it is considered as a second. And you can get those crystals in many places. So that's why you've chosen it. Even a mass has been chosen as a standard. Recently it was changed, but until now it was basically a chunk of mass which was present in the museum in France, that if you have some matter exactly of that amount, then that should be considered as a kg. So, there are, some measures, there are some features which qualify as a unit. Or else I can also say, I want a Shreyas unit of force. Why only Newton? Somebody will say, sir, I want Nagul unit of speed, or I want Abhijit unit of momentum, or I want, Vijaya unit of, electric field. No, it doesn't work like that. It has to be universally accepted as a standard, produced easily, and cannot be changed by external factors. Is that absolutely clear? Everyone understood this point? Yeah. Part by part is better, Abhijit. One shots are definitely not better at this point of time. One shots only work towards the end, not now. Okay. Fine, sir. I understood what is P is equal to N into U, meaning a physical quantity is something into a unit. Are there physical quantities without any unit? Let me ask you that question. Physical quantity without any unit. I think there are. Without any kind of unit. I think there are. Think about it. There are physical quantities without any kind of unit associated with them. You might have heard about certain physical quantities. Okay. Anybody remembers anything vaguely in your mind? Maybe in your 10th standard, there was a chapter called as optics. Yeah. Well. Refractive index. When I say refractive index, let's say of glass is, for example, 1.5. What is the unit? Nothing. It's a ratio. So usually you will see the ratios are going to be unitless. Most of the times the ratios of a similar thing, because it is sine of I by sine of R. So when you divide things with similar identical things, you will see units will not exist. Yeah, refractive index. Perfect. Yeah. Pi is a quantity, but it is not exactly a physical quantity, you would say, because it's just a number in mathematics. It's a mathematical constant. It's not measuring something every time it is changing. It is a universal constant. So it is not going to change with time and everything. Okay. So pi is just a mathematical constant. You can say it is not exactly a physical quantity. Okay. Even you will see there are more things like strain, okay, then relative, I would say, or even efficiency, efficiency. All these things are basically without any kind of unit. So do not worry, there would be certain physical quantities without unit, and if you see that, don't be scared. Okay, it is quite possible. So usually you will have the units, but sometimes there might be situations. So a physical quantity is a magnitude into unit. So N into U is the way in which you represent it. So let's solve some questions coming up on it. And before that, let me tell you and give you a list of all the fundamental quantities. Let me give you a list of all the fundamental quantities, that we have universally accepted. Everything and anything apart from this is dependent on it. So what are the fundamental quantities? First is basically mass. Second is basically, let's say, time. Then you have length. Then you have temperature. Then you have temperature. Then you have temperature. Then you have amount of a substance. Amount of a substance. Amount of a substance. Then you have current. And lastly you have something called as luminous intensity of light. Luminous intensity of light. So number 1, number 2, number 3, number 4, number 5, 6 and 7. These are your 7 fundamental quantities. Anything and everything is dependent on them. Anything and everything is going to be dependent on them. So everything else will be, everything else depends depends on the fundamental depends on the fundamental quantities. Do these fundamental quantities have units? Definitely they do have units, but what are the kind of units that you will measure or use? That is also having some conflict of interest. Like, see what happened because of historical reasons and colonialism and so many other geopolitical reasons. Certain regions prefer to measure length in miles, certain people prefer to measure length in kilometers, certain people prefer to measure length in inches, millimeters, centimeters, so many other things. Some people you might have heard, I filled gallons of fuel, but we prefer liters of fuel. Some people prefer cc, some people prefer something else, some people prefer newton, some people prefer pound, and so many other things are there, guys. So because of geopolitical historical reasons, every region has their own kind of set of units. They are standards themselves. So that's why we ended up creating many systems of units. But we will use, for our geopolitical reasons, a particular unit as a standard, which is now called as the SI system. After this, I will show you all the other units. So in the SI standards, so in the SI standard, system of units, this is called as the system of units. This is called as the system of units, which is going to be widely used, which is going to be widely used, which is going to be widely used, and it is accepted by all the scientists in the world. Because what happens otherwise, see, somebody is making the tire in one country, other car manufacturer is making the the axle, other manufacturer is making the suspension. Each person has their own unit. One is measuring in inch, one is measuring in centimeter, one is measuring in feet. So guys, when they assemble the car, it will not work if everybody says, no, I am going to stick to this only, boss. So they all need to commonly accept something as a standard. Otherwise, there will be no clarity. There will be some errors. Every time you have to sit and convert, oh, how many inches is of millimeter, oh, how many feet is a meter. It is a headache. So that is the reason why we created a standard system where we all accept, all engineers and scientists, that okay, let's follow this. So in that particular system of units, mass is measured in kilogram, kg. Time is measured in basically seconds. Then length is measured in basically meter. Temperature is measured in something called as the Kelvin scale, not in centigrade or Fahrenheit scale. Okay. Amount of substance, there is a chapter in chemistry, you will learn that. It is called mole. A mole is a collection of 6 into 10 to the power 23 items. Current is measured in ampere. Current is measured in ampere, and luminous intensity is measured in candela. Luminous intensity is measured in candela. So this is what we widely use, though there are other systems which will come to it in a bit of time. But for now, you should know this is what we will be using for most of the rest of the physics. Is this absolutely clear, and are you ready for some questions? Yeah. Electric current can be written in terms of charge and time. Yes. See, then somebody will say, sir, even speed is distance by time. Then can I write distance is equal to speed into time? Then let me take speed as fundamental, time also as fundamental, then distance will become derived. So then who decides that who is fundamental and who is derived? Yeah, that reminds me of the famous dialogue by Joker movie, Batman, if you have been following. Who decides what is funny and who decides what is not funny? So we cannot go around and shoot people that how do you decide that this is fundamental and this is derived. So it doesn't work like that. So we have to come to terms with something. So we said speed, okay, it is meters per second. There are two things in that unit. So meter is basically, length, time is second. We can measure it separately, but for measuring speed, we need two things. It is very obvious. So just by, I would say, intuition and a hitch, we go with something called as fundamental and derived, and that is something which is again universally accepted. Got it? Or else the discussion goes endless, right? Because somebody might say, no, for me, charge is physical, sorry, fundamental, and current is derived. So there is no end to that particular debate. Yes. Oops, what just happened? Something just happened over here. Yo, why did all this go? I don't know what just happened, but okay. Anyways, I'll get these notes again in the next page, not an issue. So let's start with some questions. Which one of the following physical quantities is not a fundamental quantity? Come on. All right, Deva, Sai, Smart, Hima, come on, infinite. 2 years is enough, infinite. But I know your name is saying infinite and you want everything to be infinite. Time can't be infinite. So 2 years is a finite quantity, infinite, which is more than enough to crack JEE. More than enough. Okay? You don't need 5, 10, 20 years, or else you will be like, sir, I was in my mom's womb only. I will start preparing for my JEE. My mom started preparing for my JEE, and that's how I learned in the womb only. And then I got that intellect and I was 2 steps ahead. I had already done 10 chapters by the time I was out. It's not needed. 2 years is more than enough. Yeah, the correct answer for this is work. See, which of the following quantities is not a fundamental? The word not is important. The word not is important. Luminous intensity is definitely a fundamental. Temperature is fundamental. Current is fundamental. But work definitely is not a fundamental quantity. Work depends on force and displacement. Force depends on mass. So many dependencies are there. So 100% the dependency makes it derived quantity. Next, which of the following quantities has the same unit in all the three, systems, or any system you see, you will see that, no matter what, it has the same unit. Although I have not mentioned it, but let me tell you. See, there are many geopolitical differences, many historical reasons why we have different units, whether it is mass. Mass is measured in kgs or grams or pounds. Some people will measure length in miles, some people will measure in meters, some people will measure in feet, somebody will measure in kilometers. But there is one thing, luckily, or I don't know why, everybody said, oh, we are measuring time in seconds. Oh, you too? Yes, I'm measuring time in seconds. Oh, you are also measuring time in seconds. Oh my God. So it so happens just by coincidence, there is no other reason for it. Time happens to be measured in seconds no matter where you go. Okay, time happens to be measured in seconds in spite of all the other differences that they have. So they shook hands on time, but somehow they were not able to negotiate and crack a deal on any other quantity, be it mass, length, temperature, whatever it is. Like, even you might have heard, oh, it's too sunny out there and too hot. The temperature is like, it's like 95. And we're like, what? 95 near the boiling point? Hey, no, I meant Fahrenheit. Like, who uses Fahrenheit? In India, we find it very hard that people measure temperature in Fahrenheit. But the same thing, if you go to Western country, they are like, oh, it is very hot. It is 37. Oh, it is 37? What do you mean by 37? 37 is cold for us. They're like, oh, Celsius. Oh, Celsius, is it? What is Celsius? They will talk like that. They don't understand liters. They don't understand, meters. They understand miles. So a lot of things have to do with, different regions of the world. Is that right? Okay. But time luckily didn't. So now that we understand fundamental quantities, let's go with something called as dimensions, and then I will go to auxiliary units and all of those things. All of them come together at the same time. So what is this dimension? You might have heard this word dimension. The chapter's name is also units and dimensions. What is this dimension? Let's understand it. Okay. Say for example, let's say for example, I tell you, you know, uh, area, area of something will have area of a square, area of a square, area of a square. it will be nothing but length, or let's say area of a rectangle. I will put area of a rectangle, area of a rectangle, area of a rectangle. So area of a rectangle will be nothing but length multiplied by breadth. Now tell me one thing, both length and breadth are fundamental units only, right? Both length and breadth are fundamental units only. Okay. Similarly, if I ask you, what is the surface, what is the surface of a sphere? Of a sphere, what is the surface area of a sphere? Then you will be like, I know the answer. It is nothing but 4 into pi multiplied by the radius square. Multiplied by the radius square. Now look at it carefully. Look at it carefully. 4 and pi are just numeric constants, mathematical constants. But look at other things like radius. Look at other things like radius. Forget the constants for a moment. Just forget. Radius is nothing but measured in length. You measure it in meters, kilometers, whatever you measure it. At the end of the day, it is length. And length is there 2 times. So basically, it is square of length if you think about it. Forget the constants for a moment because constants don't have units, etc. So just forget that for a moment. Length and breadth. Breadth is also at the end of the day some kind of length only. It's just that the smaller side usually is called as the breadth. So if you think about it, it is fundamentally you are measuring length 2 times. You are measuring length and length 2 times. Radius, I know you measure it once, but you are using it in the formula 2 times. Yes or no? Now, this is a derived quantity which is now expressed, How is it dependent on the fundamental quantities? What were the fundamental quantities? I just mentioned it to you over here. Mass, length, time, temperature, etc. Right? So, if I may express it in terms of fundamental quantities, and those fundamental quantities, for example, I gave them short names. I gave them something called as the short names or the symbols. For example, for length, I tell use capital L. For mass, I tell use capital M. For time, I say use capital time. So, I can say that the dimension of area is L square. The dimension of the surface of a sphere is L square. So what is the dimension? Dimension is when a physical quantity is expressed in powers of the fundamental quantity. In powers of the fundamental quantity. Like over here, in general, I can say area, the dimension of it is nothing but length square. The dimension of area is length into length, length into length, and no matter what you go, where you go. Yeah. Now, what is the symbol for dimension? The symbol that we use for dimension is this. So when I say this, it means I'm just interested in what fundamental quantities it is dependent on. I'm not interested in these numbers. So the dimension of A is nothing but L square. Is nothing but L square. That's what it means. Please understand, when I say dimension of A is L square, it does not mean A is always L square. A can be 4 pi R square, A can be L into B, whatever, but B is also measured in length. L is also measured in length, meters, kilometers, whatever it is. So the dimension of area is L square and the symbol for dimension is the square brackets. So this square brackets is nothing but the symbol of dimensions being taken, of dimensions being considered. So now let us try to figure out the dimensions of certain more physical quantities so that you get an idea of it. But before we go ahead, let me tell you what are the symbols of these dimensions. What is the symbols of these dimensions for all these fundamental quantities. So remember all our fundamental quantities. One was mass, then was length, then was length, then you had time, then so many other things were there. For now, I will just tell you, for mass, the symbol of dimension is m. For length, the symbol of dimension is L. For time, the symbol of dimension is capital T. Okay, so these are basically, your dimensions. These are basically the dimensions of the fundamental quantities. The dimensions of the fundamental quantities. So let's understand it with examples. Without that, you will not get it. Say, I tell you, speed. Now, speed is a derived unit. Can I express speed, which is a derived unit? Can I express speed, which is a derived unit, in terms of fundamental quantities with some suitable powers? In fundamental quantities with some suitable powers, 100%. Speed is nothing but distance divided by time. That is the formula. What is distance measured in? It is measured in length. What is time measured in? It is measured in capital T. What is speed symbol? It is basically small v. I am trying to find the dimension of speed. So the dimension of speed will be the dimension of length, which is in the numerator, upon the dimension of time. Whatever the unit is, at the end of the day, it is time. Whether you measure it in hours, seconds, or minutes, doesn't matter. It is time. Distance, whether you measure miles, kilometers, it is distance. So when I write it, I will write it like this. L's power is 1. Time when taken on the top is -1. So the dimension of velocity is L raised to 1, T raised to -1. L raised to 1, T raised to -1. So if you know the formula, it becomes very easy to calculate the dimension. Another example is of density. Another example is of density. It is nothing but mass divided by volume. But volume in itself is a derived quantity because volume depends on the side, height, breadth, everything. So it is nothing but the breadth multiplied by the height multiplied by the length, usually of a cube. So if I ask you, density, usually the symbol is rho. What is the dimension of density? As you can see, mass is fundamental, breadth, height, length, all three are fundamental. So I express the physical quantity in terms of fundamental quantities. Now use the symbols. The density's dimensional formula will be, mass is there in the numerator. The symbol for mass is m. Breadth, height, length, all are length and length only. So technically this will become m by basically L cube. But if you take it on the top, m raised to 1, L raised to -3. Those are the suitable powers in which the density can be expressed in fundamental terms. So anytime you have density, it will be having some mass and some power of length, which is -3. Yes, some power of length, which is -3. Understood, my dear students? Abhijit, I'll come to addition, multiplication. Hold on 1 second. So now let us say, for example, another dimensional formula I want. Let's say for acceleration, and I tell you basically acceleration, for example, is nothing but velocity and time, you take the division of it. Velocity and time, you take the division of it. For now, very simple laddu formula I'm telling you. Actual formula is something else, but this is just for finding the answer. So acceleration is velocity and time, but velocity is not fundamental. Velocity is nothing but displacement divided by time, and this time is as it is below. So technically there is a displacement over here and time square over here. Now displacement is fundamental, even time is fundamental. Can you see that? Displacement is fundamental and even time is fundamental quantity. So displacement is measured in length, time is measured in t, and there is square over here. That is the dimension of acceleration. So therefore, the dimensional formula for acceleration will be, take everything always on the top, That is the right way of expressing dimensions. Don't leave anything below. Even if it is L, write it as L raised to 1 and T raised to basically negative 2. T raised to basically negative 2. That's it. Very easy going. Sir, what about, what about force, sir? What about force, sir? Oh, wait a minute. I know what is force. Force is nothing but mass multiplied by acceleration. Oh, mass multiplied by acceleration. So, sir, can you tell me one thing? Can I just do multiplication of the dimensions also? Why not? So, the dimensions of the force will be the dimensions of mass multiplied by the dimensions of acceleration. Oh, that makes the job very, very easy because mass is a fundamental quantity. Mass is a fundamental quantity. So, the dimension is directly m. Acceleration, I just figured it out over here. L1 t raised to minus 2. You just put it over here. L1 t raised to minus 2. So the dimension of force will be M1 L1 t raised to minus 2. That's it. That is the dimensional formula for force. So if you have a derived quantity also, it's okay, provided you know its dimensions already. Is there one more example you can give me? Why not? How about work? Work is nothing but force multiplied by displacement. So can I then say the dimension of work is the dimension of force multiplied by the dimension of displacement? Why not? We can always do that with multiplications and divisions. So work usual symbol is W. Square brackets means I am trying to find its dimension. Dimension of force, we just figured it out. M1 L1 t raised to minus 2. Displacement is measured in length. So it is fundamental. So when you multiply it, it will just become M1 L into L is L raised to 2, T raised to minus 2. So that is the dimensional formula for work. Got it? Yeah? Everyone with me on this? This is how you can find dimensional formulas of everything. Sir, so tell me one thing. Can we do this? Say for example, I tell you, there is something called as total height. Example, total height. And total height is, for example, height 1 plus height 2 minus height 3. Something is there. Height 1 plus height 2 minus height 3 is the total height of some object. Doesn't matter. So, if I write like this, total height is, let's say, h. On the right hand side, I have h1 plus h2 minus h3. What should it be? Should it become h1's dimension plus h2's dimension minus h3's dimension? Do you think this is the right formula? Or basically it should just be any of these, either the dimension of h1 or the dimension of h2 or the dimension of h3. This, I think, is the more appropriate answer, because whenever you add or subtract, do not literally add it. Do not literally subtract it. It means when I'm trying to find the combined things dimension, I can add only those quantities which have same dimension. Like for example, I cannot say 5 rupees plus $5 is 10 rupees. Can I ever do that? Not possible. Only if this dollar was not there, this was rupees, only then I could add it and say 10 rupees. So it means that you can only work with similar dimensions. I cannot add length to mass. It's never ever possible. Just imagine saying length plus mass minus time. How is this even possible? This is not possible. Not possible. I cannot add time to mass or length and subtract it. Not possible. But I can multiply, divide. That is perfectly fine, like we did over here. Like length by time, mass by length. All these things are permissible. So division and multiplication, no problem. But when it comes to addition and subtraction, keep in mind they have to be of the same dimensions. Is this absolutely clear? Yeah. So the total height will have the dimension of either this height, or this height. So all the heights have to be measured in length. So the total height will obviously have the dimension of h only, will have the dimension of L only. Okay, total height will have the dimension of L only. So to come to the conclusion over here, addition and subtraction of similar dimensions is possible, is possible. Okay, but while division or multiplication, anything can be used. Any dimension, any dimension, any dimension can be used for the operation, for the operation. Very, very important rule. So just to give you the example, length dimension plus length dimension will be length dimension. If I take some mass from that, I take out another mass. What is left out is also mass. Do not say it is zero. Length plus length is length. It just says that am I adding similar things or not? Do not go with your high school mathematics and say L plus L is 2L. No. Length dimension and length dimension will be length dimension. That is the true meaning of it. What is not allowed is this. Length dimension minus time dimension is not allowed, or even time dimension plus the mass dimension is not allowed. What else is allowed over here? Multiplication. So length multiplied by time is going to be L raised to 1 into T raised to 1, definitely allowed. Or mass dimension divided by the time dimension, definitely allowed. So it will be M raised to 1 and T raised to basically minus 1. Definitely this is allowed. There is no problem in multiplication and division. Is this now absolutely clear how dimensions work? Everybody with me? Yeah? Pakka? Very good, very good. Excellent, my dear students. So, now coming to the point, sir, is it possible that, you can have a physical quantity, you can have a physical quantity with a dimension, with some kind of dimension, but multiple units, is this possible? Think about it carefully. And the vice versa, is it possible that you have a physical quantity with a particular unit and multiple dimensions associated with it, multiple dimensions associated with it? Is this possible? Which of the two are possible? And if it is possible, give an example. And if it is not possible, think why it is not possible. Can you have a physical quantity but multiple units? 100%. For example, I tell you speed. I can tell you speed. The dimension of speed is length by time. So L raised to 1, T raised to minus 1. Okay. It has a dimension. This is definitely a dimension. But if you talk about units, if you talk about the units, you can have kilometers per hour, you can have meters per second, you can have miles per hour, you can have centimeter per minute, etc. So multiple units are possible. So the answer to that, yes, yes, it is possible. In fact, many times, almost every physical quantity has multiple units. Like force, I can measure it in newtons, I can measure it in dynes, I can measure it in foot, pound unit also, everything, everything. So one is definitely possible. Can you have a physical quantity with a unit but multiple dimension? That is definitely a big, big no, because a physical quantity, a physical quantity has an unique dimension, has an unique dimension always. It can't have multiple dimensions. For example, if I tell you force, the dimension of force which we found out is m raised to 1, l raised to 1, t raised to minus 2. We just did that over here. The dimension of force was m1, l1, t raised to minus 2. It is impossible to get anything else. It is impossible to get anything else. That's it. This and only this is the dimension. So if you have a physical quantity, the dimension is fixed. The dimension is fixed. Is that clear, everyone? Let's go to the next kind of puzzle. Let's go to the next kind of puzzle. Can two physical quantities have same dimension? Can two physical quantities have same dimension? Very, very interesting. Can two physical quantities have the same dimension or even the unit, or dimension or even the unit? Is it even possible for two physical quantities to have the same dimension or even the same unit? Think about it. What do you think about this particular question? It's very straightforward, my dear students. I'll give you heat, heat, work, energy. They are all three different quantities, but they have the same dimension, and the dimension is of energy or work, which is m raised to 1, l raised to 2, t raised to minus 2. Yes, they all have the same dimension. You can also measure all of these things. You can also measure all of these things in joules. They all have the same unit. Or you can also use calories, whatever you want, or ergs. So you can see they all have same unit. They all have same dimension. So it is sometimes possible for two different things to have same dimension or even same unit. Forget that. If you don't accept this, no problem. How about speed and velocity? Speed and velocity. Both of them can be measured in meters per second. They have the same unit and they have the same dimension also. L raised to 1, t raised to minus 1. So this is also perfectly fine. So the answer to this is a definite yes. Yes, it is possible. So two or more physical quantities can have same dimension or same unit. Just because they have the same dimension or unit does not mean it is the same thing. So work is not the same as energy. Energy is not the same as heat. Speed resembles velocity, but it is not the same as velocity. So just because two things are measured in the same thing doesn't mean that they are same. For example, if I ask Shreyas sir, what is your bank balance, sir? Shreyas sir says 1000 rupees, 1000 Indian rupees. Then we ask Ambani sir, how much is your bank balance? He says something, 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 something like this. Okay, I don't know how many zeros are there. Chumma I put. Just because both of them are measured in rupees, does that mean that both of the bank balances are same? No. I'm just measuring it in the same thing. Doesn't mean that they are same. Getting my point? Everybody with me? I wish it was same, but it is not same, the bank balance. Okay? Yes, all physical quantities, I'm saying a unique dimension as in they don't have multiple dimensions. Oh, saying the word, okay, don't take unique in that way. Um, have only one dimension. That will be the better word, not the word unique. So sorry if that word unique caused any issue. Where did I mention it? Somewhere. Yes, here. Has and unique is not the right word. I should say has a dimension. Has a dimension only. Has a or has only one dimension. Only one dimension. But that dimension can be used by anything else also. That's okay. But if you are a physical quantity, you have only one dimension. Now that dimension can be shared by multiple people. Okay. So if that word caused any issue, I'm just correcting it over here. All right. Perfect. Now let's go to the next concept in dimension. Is it possible? Is it possible that you have a physical quantity? You have a physical quantity with an unit but no dimension, Is this even possible? And is it possible that you have a physical quantity with a dimension, with a dimension, but there is no unit associated with it? Come on. One of them is possible, one of them is not possible. Let me give you that hint. Yeah. Many videos are there, 2920 sets. Yeah. I'm so glad, Abhijit, it got clarified. Sweetie House, the results were declared, so we are conducting more sessions for NEET counseling and strategies, because a lot of students demanded that. So that's the reason only 2 days lectures are not there for NEET. Wednesday onwards, the classes are resuming. Okay, great. So physical quantity with a unit but no dimension. I can't even think of anything. Imagine some chumma example. Okay, something is there, kg meter cube per second. If this is the unit, 100% it will have the dimension of mass, length, and also time. So it should have dimension. So saying that it will not have dimension, I think that is wrong. If there is a unit, there should be dimension. So this is not possible. This is not possible at all. Okay, if you have a quantity with a unit, it should have dimension. So I would just say, if there is unit, there should be dimension. There should be some dimension. If there is a unit, there should be some kind of dimension. Okay, what about this? Physical quantity is there with a dimension, but there is no unit. There is some kind of dimension, but there is no unit. Now you might be wondering, wait a minute, length, mass, time, sir, all these are physical quantities. They have some kind of dimension, but do they not have unit? It is not possible. Okay, okay. Now, let me tell you, whenever you have a dimension, it is impossible that it comes without a unit. If there is a dimension, there must be some unit. Like for example, I tell you, say there is a dimension of m raised to 2, L raised to minus 3, T raised to minus 1. If this is the dimension, 100% the unit will be kg, will be there 2 times, length will be there 3 times with negative power, and s will be there 1 time with negative power. So if there is a dimension, there should be a unit. So this is not possible. This is not possible. This is not possible. So if there is dimension, if there is dimension, then there should be unit. If there is dimension, there should be unit. But I just told you one of the answer is possible, one of the answer is not possible. Sir, then how come you said both are not possible? There is a small catch in this, and the catch is over here. This is actually possible. It's just that I just did not give you enough examples. I'll tell you who is that particular quantity who has a unit but has no dimension. Who has a unit but has no dimension. Well, you might have heard about this, where the length of an arc is radius multiplied by the angle. Length of the arc is radius multiplied by the angle. Now, the dimension of length of an arc is length. Dimension of radius is again length. So, the dimension of an angle, which I do not know yet, I'll keep it over here. Can you guess what would be the dimension of the word angle, the physical quantity angle? Length and length will cancel and it will become dimensionless. There is nothing inside it. It means it is dimensionless. Dimension, dimensionless. It is dimensionless. Oh my God, it is dimensionless. But sir, we measure angle, we measure the angle, we measure the angle. We have so many units for it. We can measure it in radian or degree and so on and so forth. You can measure it in radian and degree. Oh, so it has unit, but I can't have a dimension with it. So those are two special quantities. One is angle and one is solid angle, where you have some unit, but there is no dimension for it. So this comes with an exception. This comes with an exception. This is the interesting part about this. So there is no dimension. Well, this word, it is possible. It is possible. The answer for this is possible. And the only two examples for this, the only two examples for this is something called as a angle and a solid angle. Solid angle. For both of them, they have a unit of, let's say, radian, and this is measured in something called as a steradian. Steradian, but they are both dimensionless. They are both dimensionless. These are the only two exceptions for this. But otherwise, usually, whenever you see a physical quantity which has some unit, it will usually otherwise have some kind of dimension. Is that clear? Everyone? Understood? Clear? Perfect. Yes, sir. First is possible. Yes, I played with your minds. Usually it is not possible, but only with that exception of angle and solid angle, which do not have any dimension, but you can measure the angle in degrees, radians, whatever. So 100% it is possible. So let's make a final table of everything. Let's make a final table of everything. So let me put over here mass, length, time, temperature, amount of substance, current, luminous intensity, and then the two new fundamental quantities which are auxiliary. One is your angle, and the last one is solid angle. Last one is solid angle. So we had 7 fundamental units. The last two have been added now, and that makes it auxiliary. Okay, extra, supplementary. Okay, so those are the two extra fundamental units that we have added. Okay, so let me put it right over here. So we have the 7 fundamental units, 7 fundamental quantities, you can say, and these two are our auxiliary quantities. Auxiliary quantities. Okay, so this is our fundamental 7 quantities and the 2 auxiliary quantities. Now, like I said before, there are many different systems. Earlier, mass used to be measured, let's say, in kg, length in meter, time in seconds. Then somebody decided, no, I want to measure mass in a gram. I want to measure length in centimeter, time I will measure in second. Somebody else decided, no, I will measure mass in pound, length in feet, and time I'll still measure it in second. As you can see, multiple systems still measure time in the same unit of seconds. This particular unit is your imperial system, which is also called as foot, pound, second system. This is your imperial system of units, British system, foot, pound, and second unit. This one in particular is called as CGS. C for centimeter, G for gram, S for second. CGS system. This one, M for meter, K for kilo, S for second. So this is called as a MKS system of units. This is called MKS system of units. These were the preliminary systems of units which were widely used. Later on, people discovered about temperature, moles, currents, luminous intensity, angle, and solid angle. So they had to extend it for everything else. But in British and CGS, this is not so popular. So usually in MKS, we have the extensions over here. So when you extend MKS, system of units, for temperature, you use Kelvin. For amount, you use mole, measure it in moles. Current, you measure it in ampere. For luminous intensity, you measure it in candela. For angle, you measure it in radians. And solid angle, the 3D angle, which you will learn later on, solid angle, you measure it in steradian. Steradian. This, when extended further to the other units, together this was called as a SI unit system. Okay, this was your system of units, that is extension of MKS. So a lot of people get confused, what is the difference between MKS and SI? MKS is just a smaller set of SI. When you extend MKS to the other discovered fundamental units, that is just called as your SI system of units. Is that right? All right, perfect. Arrow, hopefully see you guys soon. Yeah. The current JEE students to watch nurtures or the playlist created 3 years before. Because of that, because after that, there is Dakshin, if you want any particular chapter of the future, you can watch that. But if you want to go with the current flow, then continue with this, because live classes bring in a sense of discipline. That's the only reason. And these are also going lecture by lecture only, much more detailed, and they are really good. I mean, up to you. You can watch the older ones also. You can watch the current ones also. Watch the current one to bring in that schedule, discipline, regularity, sincerity. But if there is a class test and this chapter is not yet done, then you can watch the older series also. Is that okay? Yeah. Perfect. So, sir, you are telling me these are the widely used system. This is not so popular. This is not so popular. This is just a smaller subset. Sir, so then if I extend it to the dimensional part, then how will it be? See, mass, the dimension of mass, guys, let me put it over here. Let me put it over here now. What is the dimension of mass? The dimension of mass is M capital. The dimension of length is L capital. The dimension of time is T capital. The dimension of temperature, be careful, it is K. The dimension of amount of substance, it's MOL. That's it. No E in it. Dimension of current is A capital. Dimension of luminous intensity is C with D over here. Please remember, candela is the unit of, dimension of, luminous intensity, and candela is also the unit of, SI unit of luminous intensity. Angle is the dimensionless, so is solid angle. So these become then your dimensions. These then become your dimensions. So this chart basically explains everything what we have studied today in a gist. Isn't it, everyone? This chart is basically explaining almost each and everything, whatever we have studied today. Yeah, clear? What is the difference between units and what is the difference between dimension? Who can have units, no dimension? Who can? Is it possible for something to have unit but multiple dimensions, or dimension with multiple units? All these kind of questions I have made you study today. So let's go with some questions. So all the theory slides also I have put over here, temperature, distance, etc. How are they measured in everything? Yeah. Supplementary units, angle and solid angle, right? Okay. So let's go with some questions. The symbols of it, M, L, T, A, K, MOL and CD. Yeah. All these things are done. All right. A dimensionless quantity. What do you think? Come on. Objective questions coming up on your screen. A dimensionless quantity. What do you think? Avijit, few more minutes. Sir, I wasted class 11. Can I clear mains in 6 months? Dheeraj, definitely you can clear mains in 6 months, but you need a lot of discipline, a lot of hard work, a lot of extra time. Remove all the luxuries in life and focus just JEE. If that you can do, definitely students have done it before. You can do it too. Okay, so have faith and start going. Don't keep on searching on YouTube. Can I crack JEE on 6 months? If you keep searching, you will never crack JEE. Okay, you have to start it today. Yeah, okay, right. The correct answer is it may have a unit. A dimensionless quantity may have a unit. Like, for example, angle, it is dimensionless, it has a unit. But refractive index, no dimension, no unit also. So that's why the word may has been used. Okay, what is the dimensional formula for force? We just did it. What is the dimensional formula for force? Oh, you are in ninth. That's why you are asking this question. So, Abhijit, let me tell you, in ninth, no, the classes duration, even on YouTube, 45 minutes, 35 minutes, right? Correct me if I'm wrong. Very rarely. I've seen teachers putting marathon. I saw one teacher, very popular, very large number of marathon. And then I saw the lecture duration, 1.5 hours. I'm like, marathon, 1.5 hour, 1 hour 50 minutes, 1 hour 30 minutes is called marathon over there. So then I understood that your capacities in that grade are very less. So as you come to 11th and 12th, marathon means it is like 5 hours, 4 hours. And we call mega marathons when it is done for 11 hours, 10 hours. So we are used to that. So for us, 1.5 hour is like, oh my God, time is over, huh? So fast. It is like that for us. All right. B, very good. M1, L1, T raised to minus 2. Perfect. We just, yeah, you saw my roar videos also. Yeah. So they are all like 3 hours, 5 hours and all of that. So force is also done over here. Just check M1, L1, T raised to minus 2. Mass into accelerations dimensions. Perfect. Awesome. We just have done it. Okay. Next one. The dimensions of pressure are. Come on, you guys can do this. I'll give you a hint. Pressure 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 is nothing but force divided by area. Use this formula, you can easily get it. Strain also has no dimension and no unit, correct? That is also something which does not have unit, neither dimension. But only angle and solid angle, they both have units but no dimension. Yeah, okay. So essentially we want to find the dimension of pressure. So it is the dimension of force upon dimension of area. Force, I know M1, L1, T raised to minus 2, standard. Area is length into length, so L2. So L and L will cancel. So it will become M1 and LL gets cancelled, T raised to minus 2. LL gets cancelled, so 1 L will remain below. So it will become M1 L raised to minus 1 T raised to minus 2, because L goes on the top, it will become negative power. So M1 L raised to minus 1 T raised to minus 2 is C option. Perfecto. Awesome, Vignesh Shelaru. Great, great, great. Let's go to the next question. The SI unit of a physical quantity is Pascal second. Pascal second. Guess the dimensional formula. I'll give you a hint. Pascal is basically the unit of pressure. So basically you are telling me you are taking pressure and you are multiplying it with second. If you are taking pressure unit and multiplying it with second unit, guys, you can also take the dimension of pressure. You can also take the dimension of pressure and you can multiply it with the dimension of second. Pressure unit, pressure's dimension, we just figured it out. M1, M1 L raised to minus 1, T raised to minus 2. Perfecto. So M1 L raised to minus 1, T raised to minus 2. And then we'll multiply it with second. Second has a unit of, dimension of time. So what will this become? M raised to 1, L raised to minus 1, minus 2, and plus 1 will become minus 1. So M1 L raised to minus 1, T raised to minus 1. Where is it? Option labeled A. Very good. So guess what? This came in JEE. This came in JEE Mains 2020. Yeah, 2022. Perfect. let's go to the next question coming up on your screen. And this one is your homework question, because one question I need to give you as homework. So this is your homework question. Where are you going to post the answers? In the comments. The answer should be in the comment section. And why do I want it, guys? Come on, I want to see your engagement. I want to see your enthusiasm. Everyone, even if you're watching it recorded, it's okay, perfectly fine. Just put the answer in the comments. The answer to this question will also be there in the PDF after some time. Okay, on the next slide only you are going to see it. Okay, amount of energy per unit area per unit time. So it is basically energy upon time upon area. That is your hint. You don't need any other knowledge. So what is the solar energy concept? No need. Just look at the word energy per time per area. Just go with the flow. You are going to get it. Okay, so let's see how many of you get it, guys. And also let's take some moment to congratulate our toppers of JEE Advanced, all India rank 15. And some of you might have already seen my interviews with, Daksh and Ketan and everyone. Yeah, so amazing kids. Even Prakhar's interview, I think it should be up within a week or so. Yes, so amazing kids. Many students even did exceptionally well in their local common entrance tests. Olympiad toppers, they represented India. By the way, Daksh got 120 out of 120 in JEE Advanced Mathematics, which is the only student in entire country, not India, not even AR1 got that. Okay, so really, really cool. Kudos to all the kids. And my dear students, if you are looking for the most, private, I would say, mentorship with guidance and very few students in a classroom, and you want that personalized attention, and you want doubt support, books, and everything that a regular coaching should give. But more than that, you want somebody to drive you from an average to topper, because these students were with us from a decent amount of time. And especially if you're watching it in 10th, 9th, or even 11th standard right now, it means that you have that time which we can give you to nurture you for the next couple of years. So please visit any of the Vedantu learning centers spread across the country at so many places, be it Maharashtra, Tamil Nadu, Andhra, Telangana, Punjab, Delhi, so many places. But if you are not having the luxury of a Vedantu learning center, or maybe you prefer to learn online, that option too. By the way, Daksh was our online topper, All India rank 15, pure online. He didn't visit offline center at all. So if you're thinking just by studying online, is it possible? Yes, Daksh has proved that, and even year before that, and even year before that, we have been proving it by results. And by the way, Daksh also qualified, cleared, represented India at an international level in Olympiads. And many of the kids, even the ISI topper, which is one of the toughest exams in the country after JEE Advanced, the topper was from Vedantu, and he also studied online, guys. So do not forget to check out the links of the offline batches. You can book a slot for a demo, even for online batches. You can also book a visit to any of our offline centers. The links are there in the description box. Check it out, okay? And maybe you might find something really cool and interesting. You might suddenly understand why it is so important. I mean, it's not possible without you booking a demo or visiting the center. So just pay a visit. I'm saying just check it out. If you like it, go ahead. If you don't, it's perfectly fine. All right. So thank you so much. God bless you all. Do not forget to like the video and subscribe to the channel. Bye bye. This was your Captain Shreyas. See you in the comments.